Hello and welcome to our webinar, When to Use 3D Printing, CNC Machining, and Injection Molding, featuring our speaker, Adam Callahan, Account Executive for the Northeast region for Xcentric. Adam is an accomplished sales leader and former business owner, skilled at building, developing, and leading successful sales teams that produce results. With over a decade of leadership experience across multiple verticals, Adam sees the secret to his success as the ability to build genuine connections with people at all levels, thereby creating lasting client relationships built on trust and confidence. Adam is a father of 4 and an accomplished martial artist. Please connect with Adam on LinkedIn using the address on the screen. This presentation is expected to last approximately 45 minutes. There will be a Q&A session at the end of the presentation. We encourage you to use the questions field on your screen to ask questions during the presentation, and we will answer them at the end of the webinar. We also encourage you to follow Xcentric Mold and Engineering on LinkedIn so that you can stay up to date on our latest blog topics and webinar schedules. I now turn over the webinar to Adam.
Fantastic, and thank you very much, Mark. Hello, everyone. My name is Adam Callahan, and I am here to go over a few things, some of the differences on when and what to use when it comes to 3D printing, CNC machining, and injection molding. We will go through a couple of the goods, some of the bads, and again, this will be more of a general overview. We can get to some heavy specifics in the Q&A session, and as it stands, we'll also have a couple of poll questions to go through. So if you don't mind, we will start. All right, so I'm sure that everyone has heard of or even played around with some 3D printing, right? It has been one of the really cool up and coming technologies that's out there. Manufacturing has kind of moved itself into its own, 3D printing and 3D manufacturing has moved itself into its own right. Where folks used to think it was going to be taking over all of the manufacturing processes out there, fast forward another 20 years and it has not. But it has started to make its own name out there. It is also, of course, guys, known as additive manufacturing. And some of the times that you really want to use 3D printing is kind of varied. Right, so there are certain times, such as when nothing else can be a viable way to make it. Right, so if 3D printing it is the only way to produce the part, well, there you go. You don't necessarily need to go anywhere else. Other items, or at least other options that you utilize 3D printing for, most notably, is usually for form and fit. So form and fit is generally at the earlier stages of your projects, where you may not necessarily need a fully finished product, but you have, again, the restrictions and requirements of saying, all right, is this going to be a viable idea? Can we move forward? And that's usually, in the right at the beginning stages of your project. One of the things to note about that, or at least about 3D printing, is just as kind of a generality, it is cheaper than most of the other manufacturing processes out there. It's cheaper for the lower quantities. It's not necessarily built to scale, but if you need 1, 2, 10, and you have a few days to do it, you should be able to accomplish it. One of the really slick things, at least that I had made a note here, is a little bit of a story about where 3D printing has come from and how it can be utilized. So earlier I said, parts that aren't necessarily able to be made, via the standard CNC machining or with injection molding, and that's usually when you can go with 3D printing. One of the big things that it's kind of made a name for is some of the conformal cooling. So there's an example out there, and if you take a look at the second picture down, you'll see those little notches that are cut into a solid piece. Now those notches go all the way around. One of those parts in particular was for some conformal cooling, which basically meant that there was, in the aerospace example, is fuel that was surrounded by metal, and they needed a way to keep it cool. And there wasn't a way to manufacture this easily. And what it took was, I think 7 or 8 different CNC parts to accomplish what they were looking to do. You introduce some 3D printing. They printed it in metal, and what they were able to do was accomplish the conformal cooling side of everything in one part, as opposed to the 7 or 8. Now, it was not the cheapest out there, but it was far cheaper than producing multiple parts to accomplish the same thing. Also, it was in aerospace, so reduced parts generally means reduced weight, which means way better output. We love that, especially in the aerospace industry. One of the other really slick things about 3D printing is the availability of the printers to be utilized not only in-house at a production level or at a manufacturing level, but also you've got a lot of the home printing available. So it's definitely a technology that's out there to help. If you notice some of those pictures on the right-hand side, some of the other really slick 3D printing uses that I have seen out there, they've printed a few boats out there, which is pretty interesting. And these are, these things are buoyant, they work, they're 100% done, and they've been able to produce a boat via, again, 3D printing. That's amazing stuff. And actually, you'll see at the top of the pictures, you'll see that they've also printed, various pieces of skin or items that can kind of go over injuries where somebody may have, again, lost a bone. They have prosthetics, a finger, an arm, that type of thing, even to the point where there is facial reconstruction surgery being utilized with 3D printed items. And you'll notice that in the top, which is the ear and the nose. Now, 3D printing, a few cautions. So some of the things that we tend to maybe not think about or kind of keep you away from the 3D printing side of everything, right? So first and foremost is when you need a large number of parts quickly. If you're experienced with 3D printing, you know that printing a couple of parts can take a few hours. Depending on how big the part is, it's really going to be dependent on how long it takes. Also, there are certain restrictions on materials that you're not able to utilize. It's not nearly as versatile as some of the other manufacturing options out there. Another, generally 3D printing no-no is if you're looking for something that has a nice finished look to it without having to do a whole lot of post-processing. So post-processing is sanding, sandblasting, UV curing. You've got a variety of post-processes that happen with 3D printing that, again, it just kind of adds up on the time side of everything. Another thing that you need to be cautious about is the limitation of build sizes. So, it's a rarity to get huge 3D printers out there. So if you need something very large, it's kind of difficult to do that 3D printing side of everything. So you have to pay attention to what your build size are and what the availabilities are. And probably one of the most difficult pieces about 3D printing is part orientation and the structure, which can be difficult. So depending on the weight of the item that you're creating, you may have to, orient it in a sideways fashion and then build up a structure to hold it up while it's being printed. Nothing is worse than in the middle of a print when it has not, when you haven't developed a clean, good supporting structure, and then all of a sudden the part falls midway through the print. Now all that time is lost, and now you end up having to kind of redesign everything because, you need to introduce that support structure to make sure it stands. So that was a little bit on the 3D printing side. From there, we actually have a quick poll question, guys. So I'm going to go ahead and send that out right now. And so it is saying, asking if you know exactly when to use each manufacturing process. And this is between your 3D printing, your CNC machining, and your injection molding. All right, guys, so I'm going to close out this initial question here and then share that out. So I assume everyone should be able to see the poll results. It looks like a good portion of the folks on this call are fairly certain on when to utilize certain pieces and parts of manufacturing in their projects. So fantastic. This is probably going over a little bit of information you also already know, but maybe perhaps has some of it is forgotten. The folks out there that are uncertain, fantastic. We appreciate you popping in because we'll definitely be able to clear a little bit here for you. Now, I'm going to kick out one more poll question for you guys. And this one is related to the 3D printing and the injection molding and the CNC. So it's going to ask you, how long does it take you to get through a project from start to finish? And that does not necessarily matter on what particular manufacturing method you're using, but basically from concept, we're ready to rock and roll, all the way out to, man, this was wonderful, let's go ahead and get it done. All right, and I will close out the poll and share the results. So interestingly, on this one, most folks say it takes over that 180-day mark, which is 6 months. So 6 months from the start of a project to the finish of a project probably means you're utilizing a multitude of manufacturing methods, from generally you're starting out all the way out to your full production. A number of folks have also indicated that it is 31 to 60 days. So that is really quick, which is wonderful. You know, if you have a project that you need to get done, that's exactly where, and this is a shameless plug, Xcentric comes in, where it's a quick turn on almost everything that's out there. 61 to 90 and 91 to 180 days are pretty fair. That is usually utilizing a multitude of manufacturing methods and getting it out there. So again, wonderful, and thank you guys for sharing. Now there is going to be one more quick question, and I hate to throw this one out here, but we're about to go into CNC and want to gauge kind of where everyone's at. So the next question, and this will be the final one, we'll go through a few more slides, is asking what types of material can you utilize CNC machining for? And this is a multiple. You can choose as many as you would like. All right, guys, and I'm going to go ahead and close this out and share the results. So the fun piece about this, guys, is everyone is 100% on point with all of it, right? So metal is definitely one of the more dominant areas that CNC is being utilized. Plastic is another heavy area. Wood, glass, and foam are also items that can be machined. It's usually just maybe a different set of machines. Instead of what would be cutting metal is not necessarily the same that's cutting glass. But fantastic, guys. Thank you so much for your participation, and we'll move right into the CNC side of everything. So CNC, if you guys are familiar with additive manufacturing, quite the opposite is what CNC is. So CNC is also known as subtractive manufacturing, meaning instead of building it up, such as in additive manufacturing, you start with a large block and start taking away until your part forms. So CNC kind of spans from the start to all the way to the end of a project, because it's great for form and fit. It's great for gap production and full production quantities. Gap production, meaning if you are in the midst of a project and maybe you're going full production through injection molding, but you still need something to cover you until your molds are finished and producing. And that's what gap production is. And then when you move into the production quantities, it is almost always a better option if it cannot be molded to go through the CNC process, because once it is, once you start going into more and more, the higher the quantities, generally speaking, it becomes quite a bit more cost effective. So that leads right into that third point, which is it's generally the cheaper option as production ramps up. Especially comparatively speaking to 3D printing or additive manufacturing, where you are able to really start doing some higher end quantities without having to take as much time. And generally speaking, which moves into the fourth point, a lot of it is able to be automated. So it's, it's like the that wonderful grill out there, right? You set it and you forget it. So once it's programmed and set up, generally speaking, all that you need to do then is hit go. Once a part is finished, replace it with, another stock piece, and it starts milling again or starts machining again. And then you replace the stock and you just get as many as you need out there. The other really slick thing about this, so the polling question kind of jumped into, is you can actually use machining on a variety of materials. So glass and foam are ones that folks don't always realize machining is absolutely used on. Metal and plastics, of course, folks know about, and then wood is one of the really slick uses that I've seen. If you've ever been in a high school chop shop or anything of that nature, you'll get some metal machining and some wood machining and get some good experience there. On the CNC side, and items that you probably want to consider, smaller runs generally are not the most cost effective. So quantity 1, quantity 2, quantity 3, a good portion of your cost is probably eaten up by your setup charges and setup fees that are associated to it. Because once again, programming fees, setup fees, and so forth actually have a cost associated to them, and having to do all that for 1 or 2 pieces, can sometimes cost a bit more than folks are generally expecting. Another cautionary piece on this one is it usually requires a decently highly trained operator, somebody that knows what they're doing. And even before the operating side, you need programming involved, and you need folks that are able to put a good program through and then run a decent machine. And all of those, once again, kind of leads up to that first point of smaller runs. It may not be the most cost conducive. Of course, with CNC machining, there's also size limitations. They may be a little bit larger than some of the 3D printing out there, but you also have to, keep in mind the size restrictions and limitations that a CNC machine has. It's, and once more, if you're looking for a very large piece, it has a very large cost associated to it. One of the big parts that folks may not necessarily think of, at least as a cautionary tale when it comes to CNC machining, is it has a heavy material waste factor to it. So when you start out with, let's say we'll call it a 7x7x7 block of aluminum or steel or, ABS plastic or anything of that nature, and you're trying to produce, a 2-inch by 1-inch by 1/2 inch part, you end up, pulling tons of material off, and all of a sudden there's no place for that to go. You're not reutilizing that material. And then, of course, one of the cautionary pieces on that is it can still require some post-processing. So if you've ever, grabbed a piece of metal that is, straight from the machine, you can generally see the tooling marks, right? A little sanding or a little blasting, some polishing can remove those. Secondary processes also if you need to, tap a hole or something of that nature. So it's still able to do most of the way there, but there's still some post-processing that may be needed. So a few cautions just to keep in mind when deciding when or where CNC machining fits into your overall project scheme. So right before we move into our injection molding side of everything, I'm going to kick out a quick polling question for you guys. I know I just can't get rid of these, right? And it's going to ask basically what scenarios you've utilized injection molding in. So if you could, poll should be open, gives you the options between prototyping, production, and a bridge between prototyping and full-scale production. All right, guys, and I am going to go ahead and close this out and share the results. So unsurprisingly, majority of you guys are, injection molding is being utilized towards the end of the project where it comes through the production and then in between prototyping to full-scale production. If you guys have selected that one off, you guys have a bit of a heavier knowledge in regards to when injection molding can be used and some of the differences that are out there. And a lot of folks, actually 11% of you guys, are familiar with injection molding on the prototyping side of everything, which is wonderful because that is something that not everyone understands or knows, and it is a truly viable option, as you can go through some prototype injection molding at a relatively cheap cost, comparatively speaking, and of course make it something that can probably hold you not only from prototyping but also bring you into that gap production as that bridge between the prototype quantities out to full-scale production, and it will cover you just until full scale. Folks that are, have utilized none of the above, no problem. That's not a bad thing, and potentially we're not in the area that would utilize injection molding. But thank you guys once again for your participation, and we will move on. So injection molding, I'm sure you guys are familiar, but it is consistent of shooting a molten material into a hollowed out cavity or a mold, right? So it's basically you take two halves, you utilize a machine to mill out the overall part in a negative space. You close those two cavities together, or you close those two halves together, and it creates one cavity, and you shoot it with plastic. Usually, injection molding can be utilized in multiple areas. So from the prototype side of everything, where you need, 25, 50, 100, 200, all the way up to your higher productions, where folks go from thousands, hundreds of thousands to millions, and sometimes even greater. One of the great things, if you are unfamiliar with injection molding, is that it is usually, and almost by usually, I mean probably 90% of the time plus, is going to be your cheapest option as you move forward with production. It is where your piece part costs, it moves into that next point, are generally the lowest. So a fully finished piece that is shot through a mold and then dropped out is going to have a much, much lower cost than usually in 3D printing or CNC machining. And then one of the other parts, or the final point on that one, is it's usually one of the final steps in the manufacturing process. Most folks are not going to start producing an injection mold without having gone through the initial, form and fit. Let's test it. Let's make sure this is it before we go into the injection molding, because generally speaking, even at the prototype stage, injection molding is at that final part. You don't prototype it until you're positive that you're going to have a good, viable idea that's worth producing. Now, some of the cautions. Of course, if you're familiar, guys, injection molding generally has a far higher upfront cost than almost any other of the manufacturing processes out there. So you're sitting there, CNC machining and 3D printing. 3D printing is probably going to be much lower. CNC machining probably a little bit higher than the 3D printing, but still lower than the initial cost for the tool. Why it has such a higher upfront cost is because you're making that tool, and then your piece part cost drops down to, a couple of dollars, $1, less than $1, depending on the part, and then how many cavities. There's a variety of things that are there. But as you continue to follow a timeline, inevitably, if it can be molded, injection molding is always going to be the cheapest, because once you cover the upfront cost, it has the lowest piece part costs out of any of the manufacturing methods. Another cautionary piece on that, lead times can tend to be longer. So even in the quick turn world where, you know, a CNC part or a 3D part can be produced in a day, sometimes as quick as same day, usually 24 to 48 hours under an expedite or a standard run of, you know, 5 to 10 days depending. A lead time on even a prototype mold is usually about 2 weeks. If you're looking for a high-end production mold, generally you can even look at maybe a few months, you know, a 6 to 8 week or a 10 to 12 week delivery time. So you always have to factor that in, of course. With injection molding, there are certain design restrictions. Depending on the mold house that you utilize, whether they use inserts or lifters or, you know, anything of that nature to kind of handle anything we call an undercut, which is basically a plane that is not going to be able to be pulled from the tool very well. The other piece to this is design changes. So one of the reasons, at least that I alluded to earlier on the previous slide, is you don't pop into a mold until you're sure that it's viable. And the reason being, design changes can be very, very difficult or impossible, right? One of the easy things to think about there is if a shop will allow you to do mold changes, there's, you know, there's mold safe and there's non-mold safe, meaning you can add plastic to your part, which means taking away metal from the actual injection mold. And that is generally easier to do. It becomes very difficult or impossible when you're going the opposite direction, where you need more metal added into the actual injection mold itself, or, you know, you can utilize an insert or something of that nature to kind of fill that. So design changes can be difficult or impossible. The final piece on this one is, of course, the same thing, size limitations. So depending on how big the press is, how big the mold is, there's a variety of limits that are out there. Take, for example, think of any kind of those, you know, like a Target cart, you know, any one of those plastic carts at the grocery store, at a Target or Walmart, wherever. Those right there are made of plastic and realistically could be created in one shot, one mold type of thing. It's not. If you've ever taken a look at them, they've got a couple of different parts to them because it wouldn't be conducive, or there's a limitation of the size. You would need to spend so much more money to be able to do something that large when you could, you know, put it together in 3 or 4 pieces on a much smaller, you know, tool and press. So those are some of your cautions. All right, guys, I'm going to kick out one final poll question for everyone. And this is just kind of regarding the services that we've gone over. And we're still good, at least a little bit on that timing. So we'll open this one up for a few minutes here. And this is asking about basically what you guys utilize in your manufacturing and what you have the need for over the course of the next, you know, 4 months. All right, guys, thank you very much. I'm going to go ahead and close that and share out those results. So this is a solid mix, guys. It really, I have to say, I'm pretty surprised that it hasn't swung too heavily in one direction or the other. I would say in the scale of percentages here, all of these are fairly close. So it's fantastic, and it is, you know, nice to see that so many people have kind of a variety of knowledge and needs. We could get into a little bit more of that at the end and in the Q&A session. But thank you once again, everyone, for your participation. All right, guys, so here are just, you know, a quick rundown of some of the different decision criteria that I've handled with most of my clients out there that we kind of start to discuss right in the beginning, okay? Injection molding, generally speaking, we utilize it when there's some decent complexity in there where it will require some inserts. There's things called overmolding. Low, mid, and high volume productions, absolutely injection molding. If it can be molded, that's where you go. When you're looking for final product, so that sheen look, that beautiful polish, that wonderful piece, that's when you're utilizing that injection mold side of everything. And then, of course, it's based on certain project requirements, right? Like what kind of material, the use, the environments that they're in, again, would probably lead you to some different thoughts on injection molding. CNC parts, right? So one of the big differences between, I would say, injection molding and CNC, and even a little bit of 3D printing there, thickness of the parts. Some of the criteria is, hey, I need a 4-inch thick part that probably won't mold well. You'll get a lot of sink or something of that nature. And that's one of the biggest initial issues that you find with most folks. Volume and materials absolutely are again, different pieces that you want to think about when you're looking at CNC machining. Quantity 1, maybe or maybe not is the best fit for CNC. Maybe it's quantity 500 of that 4-inch thick part. Yeah, probably a machine job is the way to go. Always, of course, you have to consult with costs. And then, a big one that will kind of lead you to maybe a little bit of a different thought process is, does a project require colors? It's a lot easier to mold in different colors than it is to generally do a secondary process or a post process, as they say, where, you need something dipped in paint, or you need something color, powder coated, or something of that nature when it comes to machining, right? Especially when it comes to metal or even some of the plastics that come through. Getting a big chunk of purple ABS is not necessarily as easy as it would be to get a 100-pound bag of purple ABS for injection molding. Additive manufacturing, one of your biggest decision criteria on that is, where is your project? Like, are you at the beginning? Are you at the late stage? Are you in the middle? Are you at, the design side of everything? Because if you're at the form and fit, or if you're at the POC stage, which is proof of concept, generally additive manufacture is the cheapest and fastest way to get it done. Another big piece to this one is one of your big differences between machining and 3D printing is 3D printing can give you just about the closest to an injection molded piece before you actually move into injection molding or production. Of course, anything that can't be manufactured otherwise, 3D printing, additive manufacturing is absolutely the way to go. And it's, of course, generally cheaper. It's the cheapest option, usually for a lower quantity. Now, that has an asterisk there because, that may not always be the case. But if you're, doing some metal printing or printing a part in kind of a tougher plastic or something of that nature, where it may not necessarily be the absolute cheapest, but once again, that is when you have to kind of look at where you are and if it can be manufactured in other ways. So guys, I appreciate you being on. We have just a few minutes left here, so thank you very much. We're going to move over to the question and answer side of everything. So if you guys have questions, please feel free to type them in and send them out. And as they come up, I believe Mark will be able to kind of kick them over my way, and I'll be able to address them.
Yes, exactly, Adam. So as Adam said, please use the Q&A portion of your screen console to enter questions that you'd like us to answer. Adam, we have a few that have come in. One, and I think you may have just touched on this, it seems for prototyping that 3D printing is the fastest and best way to go. Is that right?
For the most part, yeah, absolutely. Especially when you're in those early stages, just because where we are with the technology, where we are with the machines and so forth, it's generally easier to kind of bust one out in a few hours than it is to kind of go over the course of figuring out who can supply it, if we can machine it, getting that way. 3D printing is a great way to get your proof of concept and your form and fit corrected.
The next question is there a big difference between injection prototype and production injection? So I guess that's prototype injection molding and production injection molding.
So there are some, one of your probably biggest differences out there between prototyping and production is going to be the material that the tool is actually created out of. Prototyping, can be fast and easy. Usually that 13 to 15 day turnaround, that 2 weeks, is usually going to be going through an aluminum mold. Now, the reasons for that is, cutting an aluminum tool or a steel tool, let's say it takes, it's basically 3 times the amount of time that it takes in regards to cutting steel over aluminum. So if it takes you 15 hours on an aluminum tool, it's going to take you 45 hours on a steel tool. Inclusive in that is a cost associated. So your cost for 15 hours of making a tool to 45 hours of making a tool is very, very different. Another piece is what the tools can handle. So production quantities, where you're sitting there, maybe your production is hundreds of thousands or millions. An aluminum tool probably will not stand up very well for that. So the wear and tear on it and the replacement of the tool is definitely a factor that's out there. Another big piece is going to be size of the tool, which will lead into how many cavities. So when you're prototyping in an aluminum tool, you could do 1, 2, maybe even sometimes a 4 cavity mold, maybe a little more depending on the size of the actual part you're trying to produce. But when you're trying to get into hundreds of thousands, when you're trying to get into millions over the course of the year, when you're trying to get into tens of millions, hundreds of millions, you need multiple cavities, and that's coming up to, some folks even have 64 cavity tools, 32 cavity tools. I've even seen a 128 cavity tool, and that is literally to be able to meet those volumes. You will not get those kinds of cavities in an aluminum tool. So generally speaking, those are some of your biggest differences between aluminum and steel tooling or prototyping to production. Now, prototype tools can handle you, generally speaking, from the start to what we call that gap production. So until you're moving into those 32 cavity molds, the 64 cavity mold, that type of thing, you will always have that backup of that aluminum tool in case that tool goes down, or when you're waiting 4 to 6 months for that tool to be created. At the very least, that prototype tool is producing parts that you're able to either utilize, sell, or do whatever it is that you're doing in your project.
All right, next question, Adam. What are the tolerances for 3D printed parts?
Haha, that is a great question and one that is not necessarily easily answered. So you have, just as various tool shops, various machines, various anythings that are in there will kind of dictate your tolerances, various materials, how you're printing, what mode you're printing in, if it's if it's FDM, if it's SLS, if it's SLA, if it's DMLS, those are all going to dictate tolerances. Unfortunately, there's not like a specific or exclusive answer to that, except for materials and the machines that are being utilized. There are definitely, when it comes to metal printing, you can usually get higher tolerances out of it, potentially less than 5/1000ths of an inch. You could probably go down to a 0.002 is where I've seen a lot of them. There's even some printing that can go even closer, okay, to 1 thou or even a 1/2 thou. But once again, it is absolutely dependent on the machine and the process and the material that's being utilized. So I wish I had a more specific answer for you, but unfortunately, it's a very broad piece that's out there.
Right, so the next question kind of plays off that just a little bit. What type of 3D printer, FFF, SLA, MSLA, et cetera, would you recommend? In what situations are each better or worse?
Sure, so it would depend on what your project requires. So there's certain technologies that utilize what they call fillers, right? So as you're producing each layer, it's a combination of your actual material plus a filler material. That's fantastic to utilize for, generally speaking, form and fit and function, but it doesn't give you the full, let's say, density rating or abilities that something printed without a filler would give. If you're looking for, let's say, very, very dense rating, SLS, anything with laser is going to give it to you exceptionally well. Anything that's utilizing UV lighting, basically, to kind of put these together, may not necessarily last up to the durability of a full-fledged piece that's utilizing a laser. And then, you know, where density comes into play a lot is in your metal printing. And if you want, you know, the highest density rating that's out there outside of being forged, you're going to be going with DMLS, which is, again, another laser style where they utilize a laser to melt each layer on.
Next question is, what common errors have you seen when people decide where to apply 3D printing?
That's a really good question. I don't know if I've necessarily thought of that before. Most of the errors that I generally see out there is their expectation of moving into production and their expectation of how easy or how quick something can be produced. Unless you have, so those 2 points more or less play off of each other. So there's, you know, let's say it takes a few hours to print quantity 1, maybe quantity 2 if you're stacking them or nesting them, as they say out there, meaning, you know, you've got 2 parts in that same build platform that you can print at the same time. Printing is going to take a while, especially compared to any of your other manufacturing methods out there. So that means in order to get scale, isn't anything about the programming, isn't anything about the automation, isn't anything about it other than having multiple machines printing at the same time. And so that's one of those great misnomers out there, is that you can get a high scale out of 3D printing. Now you can, but it comes with the caveat of, oh, you need, you know, 600 pieces and you need them in a couple of days. That means that somebody needs a few hundred 3D printing machines, depending, of course, on how long the print takes, to be able to fulfill something like that. And so that is one of probably the largest issues that we come across when people are utilizing 3D printing. Another one is the expectation of how it will look. 3D printing can come out looking really well, but generally it needs some post-processing. Most of the time when you are utilizing a 3D printed piece, you can tell it's 3D printed just because of what they call, you know, the basically layer lines. The lines of, you know, each print that goes through, and you'll see them. If I had a piece to show you guys live, I would be showing it, but you can see where those printing lines are. And that is another misnomer out there, that you're going to get something that looks as pretty as an injection molded piece.
And so, Adam, maybe you could expound on that a little bit. One of the errors we know we've run into with customers are where they think that they can jump directly from a 3D printed part, skip injection molding prototyping, and go directly to injection molding full-scale production. And it doesn't always translate.
No, well, 3D printing is it's a different manufacturing method. So how you 3D print something is not necessarily how it's going to mold. Probably one of your biggest issues, other than scale, the ability to get that many parts out quickly. One of the other pieces that you see is how it's designed. Now, a part that it can be 3D printed is not necessarily able to be molded. Secondly, if it's able to be molded, generally speaking, you have not designed it in the 3D printing process for the injection molding process. And what I mean by that is, if you've ever utilized injection molding, you know that you have to have a certain amount of draft in order for something to pull out of the tool, or in order for it to be able to get, you know, released without having what they call drag marks or anything of that nature. Certain holes, certain, you know, through holes and opens and so forth aren't necessarily able to be put into an injection molded piece. One of the other big parts of this is, or at least on the reverse hand, we'll say, is where people expect the complexity of an injection molded piece to be matching that of maybe a 3D printing piece. Whereas on 3D, if you need, an insert, if you need something to be able to screw into it, if you need any of that nature, can generally happen in what they call a post-processing facility. So after it's printed, that's when you can drill, tap, heat stake your inserts, that kind of thing. Whereas in injection molding, that all happens in one. You can usually get an insert there, a threaded insert, so that you can make the inserts right in that first shot, or have some sort of piece like a hand load that's in there that's threaded, so that you can just pull it right out as having thread in the material. So you're going to see some big differences in how parts are designed, and that's usually maybe the biggest hiccup that we get from 3D printing to injection molding. Is one is designed for 3D printing and not necessarily injection molding, and or vice versa.
I think we've got maybe time for 2 more questions, although we've got several still remaining. What material limitations are there with injection molding?
Okay, so injection molding, a big material limitation on that one is you're going to end up having a hard time with metals. Metal injection molding, not necessarily a heavily known and done thing. Other material restrictions that you can have is honestly availability of the materials. Most plastics can be molded, but let's say certain plastics that have a mineral fill or a glass fill or something of that nature, you have some heavy restrictions on those. So that is going to lead into a big point here between aluminum and steel. So if you have, let's say, something that is a 40% glass filled material, utilizing an aluminum tool is maybe not the most conducive, especially if you need some tighter tolerances and you're going to need some higher scale. So those are some of the limitations that you will have on utilizing that with maybe a prototype tool, because you'd have to skip right into a steel tool, even though, maybe you're still at that prototype stage. Other than that, most of your plastics are pretty easily utilized to mold. The other restrictions that you might have, and these kind of come with some of the minutia of when you're discussing things with designers and so forth, is how a material is going to fill. If it can fill such a small area, the viscosity of the material based on, is it going to flow like water? Is it going to flow like sludge? Other than those types of restrictions, you're not necessarily finding we can't, produce Delrin. We can't produce, this form of ABS. We can't produce, this polycarbonate. For the most part, you can. It just has certain design restrictions that are associated to that. And again, that's for form and fit, or that's for form and fill. So is it going to form properly? Is it going to fill properly? What's the uniform thickness that you need on, polycarb as opposed to ABS? Those are the types of restrictions that you're going to have, as opposed to the material necessarily.
Okay, last question is, what services does Xcentric provide?
Sure, that's a nice last question. I like that one. Services. So Xcentric Mold and Engineering is a quick turn manufacturing firm. So we handle injection molding, we handle CNC, we handle 3D printing, and kind of everything in between. So we, when it comes to injection molding, right, we'll go prototype tooling. We'll even help you out on your production tool. We even have folks that we've helped out go offshore, because sometimes if you need millions and millions and millions and you don't own your own facility, it is generally cheaper to get it offshore. And offshoring doesn't necessarily just mean China. Offshoring means just outside of the US. When it comes to CNC machining, a variety of options that are out there is what we provide. Generally speaking, when it comes to machining and injection molding tolerances, we state 5 thousandths, so 0.005 is the tolerance, and that is just as a general tolerance. Now, we have been known oftentimes to go far smaller, 0.02s or 0.002s, 0.001s. It really just depends on the part and what tolerance you're looking for, right? So a planar tolerance is different than a hole tolerance, is different than a corner tolerance, is different than, XYZ tolerance. So we take into consideration that when we say, 5 thou is what we can guarantee, but let us take a look at the part because we can go lower and smaller if you need. 3D printing, we have access to a variety of 3D printing. So it goes from 3D printing of plastics, a variety of, SLA, SLS, FDM, DMLS that are out there, and we can provide. All of this is quick turn. So CNC and 3D printing is days. I like to give the caveat of, 5 to 10, but if you really push us and twist our arm, you could probably do it faster. And then when it comes to injection molding, which is one of the greats, at least our claim to fame out there is it's a 13-day turnaround. 13 days is one of the fastest in the industry out there, if not the fastest in the industry. And that is generally speaking for aluminum tooling, of course, because steel tooling can take a lot longer than that. And obviously, that comes with the caveat of it's part dependent, project dependent. But yeah, absolutely. Xcentric handles all 3 of the services that we've discussed, and we handle the complexities that most folks out there shy away from.
So Adam, there were a few questions that were very specific to projects. So in general, if someone wants to have a discussion about a project, who do they speak with?
That is fantastic. So your first start, generally, guys, if you would like to, is you can either email me directly. And once again, if you haven't received, we'll kick out some contact information after all of this is over. But you can also jump onto our website and you can chat with us and do a live chat, which will bring you right to a person like myself or somebody else who has certain areas of expertise. And you can also email us at sales@xcentricmold.com. That one will broadcast it across everyone, and whomever is assigned to it will absolutely pick it up and be able to answer these questions directly. If you have direct and specific questions that have not been answered today, please feel free to reach out via email. And not only will I get you the answers, but I will direct you to the person that handles your company.
I would like to thank everyone for joining us today. We will be sending a link to this recording within a few days. And if you have any questions about today's topic, please email us at either info@xcentricmold.com or sales@xcentricmold.com. Be sure to follow us on LinkedIn to get all of our blogs and webinar notifications. Have a great day, everyone.
Thank you, everyone, for participating, and we'll hopefully talk to you again shortly.